now pointed at you guys. Let's everybody say hi to the internet. Now, who wants to take my phone? You can point. Hi folks, welcome. Seriously, welcome to the 2017 NYCCNC Open House. Thank you all for making the trip.
No, thank you for coming out. I love that I get to do what I do. I love making stuff, I love running the CNC machines, I love sharing that story with you guys. I always love learning, and I always love making, and I think the word that's kind of changed for me, the new word is inspiring. There's so many people here that I'm inspired by, fellow friends, fellow makers, and hopefully we're inspirational to you guys in terms of just both learning, making stuff, making it happen. The theme for me today is kind of paying it forward. We had so many people help us along the way, help us learn, help us get to where we are, and I always want to try to give back. That's one reason why it's a complete no-brainer for me to open the shop to you guys today, to learn, to do what we can. The other thing that really helps us pay this forward is our sponsors. American Rotary, CK Worldwide, and Flexarm. American Rotary has donated a 20 horsepower outdoor rated rotary phase converter, $3,000 item. CK Worldwide has donated, yeah, Jimmy DeRest is playing that, by the way. CK Worldwide has donated a TIG welding machine. Flexarm has donated an A32 tapping arm. All of these items have already resulted in us raising $9,000 to date through online raffle ticket sales. Guys, round of applause for those sponsors. You can still purchase tickets over there for those 3 items. You do not need to be present to win. I can't thank them enough. 100% of that money goes towards youth engineering, youth machining, science. Last year, we used the funds raised to buy copies of the Machinery's Handbook for the local high school machining program. We donated travel cost reimbursement for VEX robotics teams in the area that made it to state or national level competitions. And we're proud to say we had a number of teams that made it to states and above. And we endowed a scholarship for an engineering student at the local community college. Tormach, Autodesk, Lakeshore Carbide, ClearPath, and QualiChem. You guys all know these companies. They're part of our story. They're here today. They are also sponsoring this event. They've donated their time. They've donated raffle items. Talk to them today. Learn about what they do. Make use of their knowledge. That's what it's all about. These are all great companies that enjoy sharing and helping us learn and helping us make. And again, thanks to them. And let's give them a round of applause for the items that they donated. Raffle tickets are available again back there. Next to the raffle tickets is my lovely wife, who I have to say thank you to. She, yes, thank you, Yvonne. I love you. She does so much to help me do what I do. She is helping sell some of our products, and today is the release of kind of our flagship new product, which are these Tormach fixture plates. I have gone full Grimsmo on them, and we are machining them to the point where it's so, when I started, we started a rifle target business company, then moved into a hammerhead business company, and it was really fun to get stunk into production. And we chop shop, but now we're kind of moving back to production. And I love dialing that in, just obsessing over the details and the precision. It's so much fun. So we're really proud of those products. We have them here. We're offering a 10% discount today only. You can buy it here in person and take advantage of that discount, or you can purchase online with the discount code OpenHouse. But thank you to the folks that support our business with the fixture plates, with the swag, and the other products that we've got. Today's schedule, at 10:30, which is not too far away, we're going to start these workshops, these clinics. Take advantage of them. The folks that are here, I'm looking at Robin Renzetti. I mean, I'm so happy that these people are here to share their knowledge and interact with you guys, answer your questions. The schedule is here as well as on poster boards throughout the shop. Each clinic will repeat 3 times, and then in the afternoon we'll have a different set of clinics, so hopefully everybody will have a chance to take a different clinic or learn and enjoy. During lunch, we'll have Al Watmo and some folks from Autodesk talking about what's going on with Fusion 360 and CAM. And then after the afternoon clinics, we will have the raffle drawing. And then we're just going to hang out in the shop this afternoon and learn and talk and enjoy. But again, folks, thank you for coming. Thanks to our sponsors. Enjoy the day.
Quality and complication.
Sure, yeah.
You can do good quality and keep it simple.
Right, yeah, and that's kind of what I'm going for, where I don't have to do a lot of editing, because you guys talk about hours spent, and and when you've got parts to make, what comes first, right? Parts, making parts, so you kind of understand that, and it's not just, I'll do some machining, but some of it will be electronics, where kind of like how,
good at, right?
Yeah, I made a coolant sensor detection, like a level, for a Tormach with Arduino.
I like that.
Very simple.
Yeah.
Used a level probe out of a car.
Yep.
you know, and it's kind of a built-in sketch, Arduino sketch that can do that. And, you know, so I might end up making those and selling them. I could sell them for $50.
If you could do an autofill thing, so that
I could. Just you don't want to overfill. You got to have some robustness when you do that. When you're talking about autofilling. So, whoops, excuse me.
Fantastic.
Yeah, definitely.
Yeah, I mean, it's going to be an awesome event. Just talk to everybody.
Oh yeah. Well, you won't have any problem with that.
You never know what you're going to learn, though.
Yeah.
That's what's awesome.
Yeah, it's kind of.
No. He is somewhere. Yeah. He's got a blue t-shirt. He looks just like
So how long do you think do you ever plan to be in stock with a bunch of knives and have, I know a lot of your market is custom, right?
Right.
You pick your color and do all that.
Exactly.
Do you ever expect to have off-the-shelf knives, like, hey, you can buy this and I can ship it out in a week, or?
Yeah, and more like
Yeah.
that's not quite off the shelf. It could still be a custom order.
Right.
I want to get the turnaround time.
What's your turnaround time right now? I know,
Like, we've got some orders that are almost 2 years old. They're almost done.
yeah.
But we've also got, in the same batch, orders that are 3-6 months old.
Right, okay.
So I want to get all those cleared out and then have like a less than 4 week turnaround time.
Right, I know you brought your father along.
Exactly, yeah.
And that's helped a lot. And that's great.
Yeah. So just trying to, man, if we could turn things around that quickly, it'd be so nice. Even like within a week
Right.
would be just amazing. I know we have the process flow to do it. We can turn around a knife in 2 days.
Sure.
But to have like the order and the choices and all that stuff.
Sure.
Yeah.
How's the new probing on the lathe?
Pretty good.
You got it nailed down?
It keeps it all dialed in, except when it goes wonky, and then the next part is like way too big or way too small.
Yeah, the chips. Are you still getting chips in it?
No problems. Then the subspindle tries to grab onto it, but it can't or misses or whatever.
Right. A lot of error checking in there, trying to make something more
Trying
robust.
to learn as much as I can to avoid those problems, fix them.
Sure. Right.
But yeah, like for the most part, it's working really great.
Cool. Yeah.
How are you? Great.
I was wondering, I didn't see you last night. I was wondering when you were coming in.
Machinist in the Army, actually.
Excellent.
It's about and we actually developed an auto-tune program for this.
And that's
5 to 30 minutes.
That's something that even Alan Bradley does not have.
Yeah.
So there's your above and beyond on even the hundreds of thousands of dollars of
Yeah, and
Bradley.
that's actually one of the reasons why we don't do a lot of protocols.
Right.
Because some of those features that we've developed wouldn't be compatible. So that auto-tune that people have been raving about,
Right.
it wouldn't be possible.
Right.
You know, or it'd have to be heavily redone. The algorithms that are PIV loops,
Yeah.
that are a bit more sequential than PID,
Right.
they might not be possible with some of those protocols.
Sure.
So it's like a lot of that stuff is, really makes our stuff high performance. Like that 80 to 1 mismatch is
Sure.
8 times the recommended maximum mismatch that, some of these other
Everybody would allow,
Exactly.
right?
Yeah, and if you look at that, it's like, stopping right on a dime at 2,500 RPM.
Yeah. How do you handle the homing? Do you use a torque feedback to set home position, and then you do an error tolerance adjust?
We actually have developed a hard stop homing algorithm where it monitors a number of features, not just the torque, but it monitors position and velocity.
Okay.
So when it gently clamps into the hard stop,
Sure.
it's going to recognize that the tracking error is drastically increasing, the velocity's hit zero,
So,
the torque's
yeah, so
spiking.
kind of like a position error in my terms, right?
Yeah, but it's monitoring all these parameters simultaneously, and when it hits certain thresholds, it
Gotcha.
labels that.
So it can be a rubber stop, then, example.
Yeah, a hard rubber stop.
Unlike a servo, a lot of times it must be a hard stop. So
Yes.
otherwise it can bounce. Right?
Yeah, and obviously, the harder it is, the more firm and repeatable.
Exactly,
position.
and then there's no wear to a hard stop where that rubber, 100 times it may deflect X number.
Exactly, and what's really interesting is with good mechanics, it's repeatable to 1 or 2 pounds. So, I mean, compared to like, so some sort of limit sensor.
What is the encoder resolution on that?
That's a good question. Actually, underneath the covers, it's a 12,800 per revolution encoder. So there's 2 different commandable resolution options that we offer. One, the standard is 800 counts per revolution, and an enhanced where it's a bit more money, but it gives you the ability to command the 6,400. And those are all positions where if you're ever work with steppers, it's very different. Because it actually can reach those positions full torque, and it always positions to the encoder resolution into the cover. So you have that repeatability to like underneath.
So I'm about to order some. What's the difference between, say, your high-powered and your low-power? The ones that say 2 to 3 times versus 8 times. The stepper. What's the main difference between the two, other than because a lot of the specs, when you look, are very similar. Some of the speeds and stuff are the same. What would be the difference?
So the big difference between there's 2 differences. One, the primary difference is the high power version has much more peak torque. So let's say you want to do more throughput, then I mean obviously you're going to get more throughput than the stepper. But if you want even more, that's going to be one big benefit of that. And to give you an example,
does that translate to acceleration also?
It does. So right here, if you look at this is running at 3,000 RPM. So you can see it's hitting torque saturation. Which means, and it shut down because it was accelerating a bit too fast.
So you can see you can kind of see the limits right there.
And that should have shut down. Jog it a bit more.
Does it require homing if it loses position? I mean, I'm assuming it's an absolute encoder that...
So I'll get to that question in 1 second, but I don't know why the tracking error tripped there, but the tracking error is one of our safety features, which in case you accidentally drive into a hard stop, it's able to shut down for safety reasons. But the reason I was showing you that torque stat message is it was accelerating as fast as the peak torque would allow because this has a cost-reduced drive, because we realize not everyone needs that servo power. You don't need to pay $500 sometimes for that. But if you do want that extra throughput, that's one of the big advantages of the high power. The other is it has that higher resolution as a standard option. That's 6,400 pounds. But if you don't need the power and you just want the resolution, you can get that as an add-on option for the lower power stepper version. The stepper killer. So as to your other question, you were asking about...
I don't remember now. You have very good documentation as far as some videos about the positioning and stuff. So
we actually do all of the videos in-house. Some of our senior engineers write the scripts for that. Company heads, and the documentation is written by engineers. That have technical writing experience.
And they talk in real language that people in the kind of industry. So I mean, if I'm say I'm going to make a product, choosing, I mean, just like right here, this table, using the clear path, it's kind of like, okay, they've done their homework, they're using a real system, it's above a normal stepper setup, so, that right there.
So right there, the blue trace that I saved is the torque, and right now, we can view the velocity profile that it's sending.
Right, and all of that is set by your auto-tune too, right? Some of those profiles?
Oh, well, the profiles are generated in this move generator. But if you're sending like step and direction signals, this is the profile you'd see.
From the output from your controller to the...
And another great thing about this is, let's say you have some sort of pulse problem, which not very common, but once in a blue moon, someone will have like a really low-end step and direction output that's giving a choppy signal.
Using a bad computer, rather.
Where I've seen signals that the velocity is varying by like 50 RPM within milliseconds, and they're like, "Why is my performance not smooth?"
Not possible, right?
And we're like, and all you have to do is run the software and be like, "Hey,
this is a game changer for troubleshooting. This being connected. You can run your program where it's faulting. Yeah.
Exactly.
So you can actually have your own controller running this thing and still read the diagnostic?
Yeah, and it has essentially no impact on the performance.
Yeah.
Which is really great.
This is the hydraulic.
Yeah.
That's awesome.
It's our new 110.
Yep.
This is our new 110 unit.
Yep. What is that? Half inch 13?
This is a half 13,
Yep.
mild steel.
What brand tap?
We use OSG taps.
OSG. Okay.
Oh, so good.
That's so good.
Let's find a hole that hadn't been tapped. Run it down. Clutch out at the bottom.
Gotcha.
Take it back up.
You really crash. You actually crash. You just let it.
Yeah.
Yeah. Got
Just
chuck
run
on it, huh? Yeah.
Got a built-in clutch. Got
Mechanical. Yeah.
a quick change.
Gotcha. Sweet.
You can go from different sizes. Here we're doing 3/8, I believe.
Yeah.
Same thing, go down, clutch out at the bottom,
Cool.
run it back up.
I mean, do you have to adjust the clutch for the different tap, or?
You can adjust the clutch. So each tap holder, you just pop the retaining ring out,
Yeah.
take that spanner wrench. Let's say you're doing some stainless, take it right. Doing some aluminum, take it left. So just
That's as easy as it is.
fine tune it per your material. And we can tap anywhere from odd 80 up to 2 inches. So,
Wow.
made here in the USA.
I like that.
Yeah.
What's the price on this bad boy?
This one is $4,900. Our biggest seller here is $2,900.
Yeah, but that ain't bad considering you have that whole power unit. I mean, that's a lot of the cost right there.
You get the arm, you get the whole hydraulic pump.
Oh, it's hydraulic.
Yeah.
Oh, yeah, that's. I mean, that's nice, but this one, if you're gonna do 1,000 holes a day,